A 13-kilogram rock is dropped from rest on the Earth and reaches the ground in 1.75 seconds. When it is dropped from the same height on planet X, it reaches the ground in 18.6 seconds. What is the acceleration due to gravity on planet X? Let us have the given. Given we have the mass of the rock will be irrelevant. We'll just be using the time. So the time of this rock to drop from rest on Earth is 1.75 seconds. Let's say this is T sub E equal to 1.75 seconds. And the time on planet X, when the stone is dropped from the same height on planet X, it reaches the ground in 18.6 seconds. Let T sub X be the time for planet X, and the time is 18.6 seconds. Both the initial velocities on both planets is zero because according to the problem, it was dropped from rest. Now we are required to get the acceleration due to gravity on planet X. Let's say g sub x, acceleration due to gravity on planet X. So let us solve for this problem. So we all know that from the problem, the stone is dropped from the same height on planet X and on planet Earth. Therefore, let's say that y sub e is equal to y sub x. This is equal the height, the vertical height. Now, from our equation, y is equal to vit plus 1 half g t squared. We can get the gravity on planet X. Of course, this term will be equal to 0 since the stone will be dropped from rest. So the initial velocity is 0. So y will just be equal to 1 half gt squared. Now following our first equation that y sub e is equal to y sub x. Now we can substitute now this equation. We'll have 1 half since y sub e will have now y sub e is equal to y sub x. So this is equal to 1 half gravity on Earth. Let's just say it's g time on Earth squared is equal to 1 half gravity on planet X time on planet X squared. Let's just cancel 1 half. We'll have g time on Earth squared is equal to gx dx squared. Now we are asked to get for gx divided by tx squared divided by px squared. So we'll have gx, this will be cancelled, is equal to g time on Earth squared all over time on planet X squared, where g by magnitude on Earth is 9.8 meters per second squared times the time on Earth according to the problem is 1.75 seconds. So this is 1.75 seconds squared, and the time on planet X is 18.6 seconds squared. So let's input this in our calculator. We'll have 9.8 multiplied by 1.75 squared all over 18.6 squared. The answer would be 0.0867 or approximately 0.087 meters per second squared. Gravity on planet X is 0.087 meters per second squared. So this is now our answer.